Hello guys, welcome back to your differential calculus. So we are now on your application of the concepts that we discussed. Okay, so we are now on the application of the concepts that we discussed in derivatives or in differential calculus. Okay, so before we will move to the transcendental, differentiation of transcendental, let's first try to have applications for those of the theorems or concepts that we discussed before we will move on to your transcendental functions. Okay, so we discussed the derivatives of algebraic. So let's try to apply it first before proceeding to the other types of functions. Okay, so these are the applications we will be discussing here. The tangent and normal lines, what is increasing and what is decreasing function, maximum and minimum values of function. Okay, so in here we will be graphing equations. We will be finding the maximum and minimum values, and then what is the significance of that second derivative, and then maxima minima, that is the application of your maximum and minimum values of function, and then related rates, or this is what we call the time rates. And if we have extra time, let's try to tackle your rectilinear motion. But if not, then you can just read about this, or this will be discussed in your physics or in your dynamics of mechanics. Okay, so let's start with your tangent and normal lines, how derivative is applied in there. So this is a recall from your previous module that I've discussed before, wherein again slope. So that is just the slope, but the important here is that m is the slope, and that is just equal to dy dx, or that is the derivative of y with respect to x. Or if your variable is different variable, let's say t or s with respect to t, then that will be ds dt. So it doesn't matter what the variable is, okay? You will be plotting those one. If that is not y, then that will be different. Okay, so the derivative of a function is the slope of its tangent line at any point. Okay, I discussed this one on the previous module. Okay, so again, if you will get a derivative of a function, let's say this is your function, y is a function of x. The derivative of that is representing the slope at any point. Okay, any point that you will consider within this function. The slope of that tangent line, again, if we say tangent line, that is the line passing at a point that we are considering on the curve. Okay, so the first derivative, or the y prime that we are talking about, is just the slope of any point. Okay, slope of the tangent line of any point on the curve. So again, this is a recall. I discussed how this delta y, delta x, dy dx is derived using this figure. Okay, so we have here your tangent and normal lines. But before we will go there, a brief recall on your analytic geometry, or if you discuss this one in your algebra. Okay, let's try to talk about, since we are talking here of lines. Okay, so let's go back to the general form of line. If you say general form, that is the general form of writing the equation of a line, and that is written in a manner ax plus by plus c equals 0, wherein your a, b, and c are just the coefficients or numbers, and x, y are your variables, and this is a line. Why? Because x and y are on the first degree. Okay, that means within one value of x corresponds to one value of y. So we are just, if we are going to plot those one, those are just single points, and if you will connect that one, that will be straight line. Okay, that is the general form of your line. Ax, or number x, plus number y plus a number equals 0. Okay, so if we will try to rewrite this one into forms, we call this one the standard forms of line. Wherein if you will rewrite this one into these forms, we will be having parameters of line. If you say parameters, it will be the characteristics of line. So let's start with the first standard form. We call this one the point slope form, PSF. This is the form of that, or this is the form of the line, equation of the line. For in this equation, that is m equals y minus y1 all over x minus x1. If you will try to recall this one, that is coming from your delta y over delta x, isn't it? In the previous discussion or in the previous slide that I've shown you a while ago. Delta y delta x, or that is the change in y, change in x. However, we will not be substituting 2 points, only 1 point, that is the value of point 1. Let's say point 1, we have 1 point, that is the point where the line is passing. So that is x1, y1 only, wherein the other point is considered variable. That's why xy, so that you will have an equation, because if you will not have there a variable, then that will just be a number or a slope itself. Again, so m there is a slope that is coming from this. If you do not know the slope and you are given 2 points, all you need to do is substitute in this formula, or that is the change in y, change in x. Okay. X and y, of course, the numbers here, of course, are your coordinates of the point that we are considering. So why do we call this one point slope form? Because if you will try to look at the equation, you have there the slope. Okay, isn't it? You have the m, that is the slope. Why do we call it a point slope form again? Because we have there a point and a slope. You have this slope m, you have that point x1, y1 located at x1, y1. Okay, you have the coordinate of the single point. So you can find in this form, if you will try to rewrite from this general form, rewrite it in this manner by playing the algebra part, you will bring out the slope and bring out a point where the line is passing. Okay, so that is point slope form. Second standard form is your slope intercept form, or SIF. So what do you expect? You will be having their slope and you will be having their intercept. Okay, so this is the form of that, wherein y is only separated there, equals m, or a number, that is your slope, multiplied to x, so that is the number paired with x is the slope. Okay, that is the slope, plus b, wherein b is the y-intercept. If we say y-intercept, that is the value of y where the line will intersect. Okay, let's say this is your axis. Say that is your y, that is your x. Let's say that is the line. Let's say that is your line. The y-intercept that we are talking about is this one, that is the b. The value of y where the line intersects, that is your b, or y-intercept. Okay, so if you rearrange this one, you will find again into this form, you will find there the slope, which is just the number paired with x, and the number at y where the line will intersect. Okay, that is your b. And related to that, we have here the intercept form. If we say intercept form, we will be having there both intercept, the y and x intercept. Okay, x intercept is where the line will pass your x-axis. So you have there in your formula your a and b. X and y are your variables. You have there below this number, you have there below this, what do you call this one, variables, your numbers, wherein those numbers are your intercepts. Okay, those are your intercepts. So a is x-intercept. Okay, that is just a brief or short recall about your lines in your from your analytic geometry. We have here, of course, important also that we will recall the relationship of lines. Kung kayo may relationship, ang lines meron ding relationship. Okay? So we have here the first type of relationship, or first relationship of lines. We call that one parallel lines. Wherein if we say parallel lines in this figure, let's say your green is the line 1, and this below, the black, is your line 2. They are called parallel. Why? They are called parallel because, okay, they are called parallel because they will never meet. Even if you will extend both of these lines, they will never ever meet because the distance from these two lines will always be equal all throughout. So they will never ever meet. Kahit i-extend mo pa yan, hindi talaga sila tinadhana. Okay, so that is parallel lines. Okay, so regarding the slope of this, if we say slope again, because that is what we are trying to investigate in lines here in calculus, the slope of these two lines are always equal if they are parallel. Okay, they are always equal if they are parallel. And then perpendicular lines. Okay, by the way, please again recall, if we say parallel lines, it is symbolized by this one. Okay, by this symbol. So you can write these parallel lines as L1, this symbol L2. That means L1 is parallel with L2. Okay, that is parallel lines. Parallel. And then you have here your perpendicular lines. That is the other special relationship. We say perpendicular lines. Again, look here in the figure. These two lines, we are talking here of two lines, they intersect. Okay, they meet at a right angle. So parang kayo lang ng jowa mo, kung kayo talaga, you meet at a right time. So they intersected at a right angle, just like the x and y axis. The angle between them is 90 degrees. We call that one perpendicular lines. And if we are talking about the slopes, the relationship of that will always be, okay, the slope of the other one, of the other line, is equivalent to the negative reciprocal. Okay, negative reciprocal of the other line. So if that is L1 has the slope of M1, L2 has the slope of M2, then M1 is the negative reciprocal of M2. Okay, those are the slopes. And M1 and M2 are the slopes. So how do we write that one? L1 is perpendicular. That is the symbol for perpendicular. It is a 90-degree lines. Okay, perpendicular with L2. Again, symbol for perpendicular. So it means line 1 is perpendicular to line 2. That is your symbol for perpendicular. Okay, please do not forget about this. Parallel, perpendicular. Okay, so how about later on you will end up there, because especially here, look at this, if you have M1, this will become, because of that negative, it will reverse the sign of the other slope. So later on you will be having there a plus and minus. So I think you should already know about this, but just a brief recall for those who forgot. A positive slope, okay, these are the signs of your slope. Let's say a positive number for slope, that means the line is rising from left to right. Pataas po yan. If that is positive, your line is going up from left to right. So let's say that is your line, that is positive slope. And then negative is the reverse. The line is going down from left to right. That is your negative slope. Okay, so that is a short recall in your analytic geometry before we will proceed on the equations of tangent and normal lines. Okay, so let's start now. So let's start. Let's say, okay, since we are talking here of normal and tangent line on a point, okay, so let's say this is your function. The red is your function. Let's say that is y function of x. So your variables are y and x. And you will consider there a point, single point on the curve. Let's call that one as P1. That is the point of tangency. That is where the tangent line and the normal line will pass. Okay, so let's call that one P1. So you have there your coordinate, and again, let's say the line passes that is tangent to that point. Okay, this is your LT. Let's say that is LT, that is your tangent line passing at point P1. The slope of that, again, going back to what we discussed before, the slope of the tangent line is the first derivative with respect to x, or that is the y prime. Okay, so later on, if you need to solve the equation of the tangent line, you will be using the slope, which will be derived from the first derivative. Okay, that is now where your derivative will be coming in. You will be using the slope, which will be coming from your first derivative, for you to end up with the equation of your tangent line using your point given, okay, which is your P1. So you have a point, you have a slope, then we will reverse the process. We will make use of the point slope form. Okay, since again in the point slope form, what you need there, what parameter of line that you need there is a point and a slope. So your point is your P1, where the line will passes, and your slope is coming from the first derivative. Normal line, again, if you say normal line, by the way, normal and tangent lines are perpendicular. They are perpendicular. Okay, so that's why we have here the symbol 90 degrees. The square means, that means they are on 90 degrees. So let's say that is LN, that line normal or 90 degrees with the tangent. Okay, that is your normal line. The same, of course, it is passing at P1. Let's call that one LN. The slope of that, since they are perpendicular, okay, recall the relationship of perpendicular, that the slope of the other is the negative reciprocal of the other one. So we will follow that one. So your slope of MN is just the negative reciprocal of your slope in tangent line. Why they are 90 degrees or they are perpendicular. Okay, that is your point of tangency. So let's have an example for that. So in this problem, it is being asked for you to find equations of the tangent and normal lines to the curve y equals x cubed at point 28. Okay, so we are trying to find equations of your tangent and normal lines that is intersecting or passing at a single point in your curve y equals x cubed. And that point of tangency is 28 at 28. So solution. Again, okay, solution, going back there is that if you want to solve the equation of the line using, okay, what do we get? We can get the slope from derivative, because again, the slope of the tangent line is the first derivative of the equation itself. So you have there your m, and you are given a point. So what are we going to use? Your point slope form. So first of all, you need to have the slope, you need to have a point. So that is what we are trying to do first in your solution. Okay, so for me, I want to get first since we are given already the point, you do not need to worry about that. So we are going first to differentiate, get the first derivative, because that is the slope of the tangent. So if I will now differentiate this curve, that will be y prime 3x squared. So that is a simple power rule. But of course, we need a value. We need a value for a slope, because we need a number, okay, to substitute in the point slope form. So the slope of a tangent line at 28, of course, the substitute. What do we need in this equation is only x. So I only need x. Substitute the x. Then the y prime, or that is the slope now of your tangent line, is equivalent to 12. Okay, that will be 12. Now, since you already have the point, which is at 28, and the slope of the tangent, which is at 12, or equal to 12, we can now evaluate the equation of the tangent line, since what is that? The slope of tangent. So point slope form. Your slope is 12, which is the tangent. A point where it passes is at 28. So x, y. Please do not interchange this one. Now put in your mind that the slope is always change in y over change in x. Y over x. Okay. So y minus 8, that is your y coordinate. X minus 2. Okay, please take note of that. That will always be minus, because we are taking here of change. So if you will be having here, let's say, a coordinate of negative, it will make that one plus. Okay, so substitute the value as is. and then follow what will be the sign. So x is 2 and y is 8. Substitute and then play around with this. Cross multiply. This is now algebra part. So this I will take this one as a single function. Cross multiply on the other side so that I will, of course, your answer will always be on general form. General form of line again is number x plus number y plus number, if ever there is a constant, equals 0. Okay. So cross multiply your cross multiply your x minus 2 on the other side. Everything will be multiplied with 12. Please, that's why it is very important for you to put there a grouping sign. You are multiplying a multiple term into a single, or if you are dealing with the multiplication of a multiple term. That is your common mistakes in your solutions before. I don't know if that is really a mistake or you did not copy. Right? Okay. So that's it. Multiply. Since again we have a grouping sign, means everything is multiplied with 12. So that will be 12x and that will be 24. And of course transfer both of these on the other side so that we will put this one on the form ax plus by plus c. So x, y, and then constant. So that will become 12x, okay, positive. Y will go on the other side as negative, yes. 12 times negative 2 will be negative 24, and 8 will go on the other side as positive, so it will combine into negative 16. So that is the algebra part. I do not need to discuss that one in detail. So therefore, this is the equation of your tangent line. That is the equation of your tangent line. Why tangent line? Because we use the point toward the tangent line passes, and we use the slope of the tangent, wherein that is the first derivative. Okay, we are done with tangent. How about the normal? Okay, normal line. Of course, for you to have the equation of normal, you need to have the slope and of normal and the point, which is the same at 2, 8. So we already have there this point. All you need to do is find the slope of normal. And do not say that that is also y prime. No, y prime is just the slope of your tangent. So what are we going to use? Again, going back to my discussion a while ago, the normal and tangent lines are perpendicular. Since you already know the slope of the other line, wherein that's the tangent, you can make use of the relationship of perpendicular slopes or perpendicular line, the relationship of slopes. Since we have there the empty, then that is the one to be there since we are solving Mn. If let's say the other way around, you will solve empty from Mn, interchange, just cross multiply. Okay, so I will be using the reciprocal, the negative reciprocal, which is empty is 12. Therefore, your Mn is negative 1 over 12. Okay, so you have now the slope of that. Please do not put your slopes on decimal, because if that will be decimal, especially if that is a decimal with no ending, and you are rounding that one and you are using a rounded value on equation, that will not be an exact equation. If we say equation, that should be exact. Okay, so as much as possible, we should get rid of rounded values or rounded decimal on equations. Okay, so just take it as is, 1 over 12. Take it as is. Carry that one as your slope. So again, point slope form. But now we will be using your slope of normal since we are finding the normal line, and the point where the two lines passes are the same, so I will be using 2, 8 also. Mn will be negative 1 over 12, that will be the same as this. So again, you have the negative 1 over 12 or negative fraction. Again, negative means you can put the negative on top or you can put the negative below. It doesn't matter. It doesn't matter where you will put the negative, as long as, okay, please take note, from algebra on, you should only use the negative once. If you use that one on the numerator, do not put that one at the denominator. Okay, or if you use that one at the denominator, do not use that one in the numerator. So let's say I want to use that one in your 1, so that will become negative 1. Cross multiply your x minus 2. It will go negative 1 multiplied to that x minus 2. And the 12 here, again, do not use the negative with 12 because I already used that one. will be positive 12 cross multiply on the other side, it will be multiplied everything here in your y minus 8. So play with this algebra, that will be negative, positive. You can transfer always. First term should be positive. So instead of having negative x there, I will transfer all of this on the other side, so that x positive 12y, this is positive 4, it will go negative on the other side, and that is 12 times negative 8, so they will combine as negative 98. Check that one using your algebra. That is just algebra. So again, this is your equation of normal line, since we use the slope of the normal and we use the point for the normal line passes. Okay, that is equations of normal and tangent lines. Okay, so we will have one more example for normal and tangent lines before we will proceed to the next unit of this module. Okay, so let's have a second example. Find the tangent line. So we are only finding the tangent line to the curve x squared plus y squared equals 5 and parallel to 2x minus y equals 4. Okay, so there is just a little bit twist, but what you need here again is your just simple analytic concept. Okay, so we are finding a tangent line. That line is tangent to this curve, and at the same time that line that we are trying to find is parallel to this. What is this? That is a line. Why? Because that is only x and y. Again, you can just look at the exponent of the equation, you can say that is line if there is no more than first degree. Every variable should be first degree, or that is x raised to 1, y raised to 1, so automatically that is just a line. So again, you're finding a tangent line tangent to this curve, at the same time that tangent line is parallel to this line here given. Okay, so solution, we will always start, since what we can get from derivative is a slope, we will always start with your point slope form, unless you are given the what do you call this one, you are given the intercept, so that you will use the slope intercept form. Okay, so most of the time in normal and tangent lines, what form of line is used is the point slope form. So seldom that you will be using your slope intercept and your intercept form. Okay, so again, y prime, first derivative with respect to x is the slope of your tangent. So I will be needing the first derivative of this, so I will differentiate your curve. Okay, so that will be power rule 2x, that will be 2y dy dx, or y prime. Derivative of 5 is 0. So I will bring out y prime here, play around with this. Again, that's algebra. That will be y prime equals negative x over y. Therefore, that is the slope of our tangent line. But in your first example, you are given the point of tangency. But in here, we do not know yet the point of tangency. What we know is that there is a line parallel to what we are trying to find. Okay, so we will make use of that relationship. The relationship of the unknown line with the given line, which is parallel. So let's leave this one as is. Let's leave that empty to be negative x over y. Slope is negative x over y. So I will try to make use of the relationship given. So tangent line, the tangent line that we are finding is parallel. Let's call this one as line 1. Okay, this line given here, let's call that one as L sub 1 or line 1. Okay, so that we have name for that line. So tangent line is parallel with this given line, line 1. Therefore, if they are parallel, again, make use of the relationship. If they are parallel, their slopes should be equal. So if I will know the slope of your line 1, that is the same as the slope of your tangent line. Okay. So again, I will repeat, since the tangent is parallel with the given line, line 1, their slopes are equal. So if you will know the slope of line 1, that is the same as the slope of your tangent line. So what will I do? I will find the slope of line 1. How will I do that? There are two ways. Okay, you can still make use of derivative. Again, always the first derivative of any function, if you say function, it could be a line, a curve, what type of curve is that? As long as the first derivative or y prime of that will always be the slope. Since that is just a line, okay, if I will to get the first derivative of this line, that will be 2. 2x will be 2, minus y will be minus y prime, and the derivative of 4 is 0. Therefore, I can play around with this so that y prime is just equal to 2. Or since y prime is your slope of the first line, that is the same as the slope of the tangent. So therefore, you have already there the slope of your tangent, mt. Or if you do not want to make use of the simple solution derivative, you can still go back to the standard forms of line, wherein you can rewrite this one into the slope intercept form, the SIF, wherein in this equation you will find the slope and the intercept. So again, going back, that is y equals mx plus b. Y is equal to mx plus b. So I will rewrite the equation into that form. Y will always be positive, okay? That should always be positive. So that will go on the other side. 4 will go with 2x. So y will be positive. 4 will go positive. Sorry. Yes, negative. It will go negative on this side because y will become positive. So it will become negative together with your 2x. So again, y is equal to mx plus b. So the number paired with x is your slope, isn't it? So that is positive 2. So therefore, that is the slope of line 1. At the same time, since they are equal with mt, that is also the slope of the tangent. So later on, if you will need the intersection of the line with the y-axis, that is the b, or the y-intercept, that will be intersecting at negative 4. It is given here. Okay, that is the slope intercept form. So that should be the same. Yes, they are the same. So it's up to you what you're going to use. Okay, so now you have the slope of the tangent. All we need to do is find the point of tangency. Again, point to slope form, you should have the slope and you should have the point. We only have the slope, which is 2. So what will I do? I will solve the point of tangency, x1, y1. What will I do? Look at this. I did not yet use your first derivative here, or the mt equation. So I will equate mt with mt. You have their mt, and the value of mt is 2. So I will equate them. Yes, since they are equal, so they should be. So mt is equal to mt. Mt is negative, mt is 2. The slope is 2. So I will substitute there. And then mt is the other equation, negative x over y. So I will play around with this. You will be having 2y minus x, or you can put the negative on the other side or divide by negative so that x will become positive. Okay, because I will be needing this one later on. That's why I am simplifying into this form. But it's up to you how you will do it. So for me, I will carry negative with your y, that will go on the other side as negative 2y. So x will be equal to negative 2y. Again, what are we trying to solve is a point. What it gave us is an equation. So let's say that is equation 1. What equation is this? That is the equation of the point of tangency. So we need to solve the values of x and y. And you have that one equation. In algebra, you have two variables. And if you want to solve the two variable or the values of the two variables in the equation, you should have another equation. Isn't it? The number of equation should be the same as the number of variables so that you can solve these values of variables. Equation should be equal to variables. So we have here two variables, two unknowns, x and y. So we should have two equations. So let's say this is just the first equation. I need a second one. So what will I use? There are a lot of equations here if you try to look at this. But, okay, there are two equations here. But, think of this. You are trying to find a point. Okay, let me explain this one. You are trying to find a point. Let's say this is your, for example only, okay, I will not draw it accurately first. Let's say this is the curve that you are talking about. Let's say that is the point. that is P1, which is located at x1, y1. This is what we are trying to solve. And that equation x minus 2y is the equation equals 0. No. X is equal to negative 2y is the equation of the point, since we do not know what point are we considering here in the on the curve. So I need the second equation. What will I use? Let's say the given is the equation of the curve. That is x squared plus y squared equals 5. And we have a given, other given. So let's say this is the unknown. So the tangent line is, let's say that is the tangent line. That is the unknown. So you are given, let's say this is the other given line, parallel to the unknown line, tangent. Let's say we have there another line given, which is the 2x minus y equals 4. Which of this equation are you going to use? The equation of the line or the equation of the curve? Okay, put this in your mind. You are trying to find, this is the equation of your line. So I mean the point that we are trying to find, equation of the point. So what we are going to use as other equation should have a relationship, should have something to do with the point. So if you try to say, I will use that line, equation of line, that does equation has something to do with the point, voila, isn't it? There is no relationship with the point. But in this curve, that point that we try to find lies within that curve. So I will make use of this as my equation 2. Why again? We are trying to find the point, and this is the equation of the point. We need one more. I will use the equation of the curve. Why? The point lies within the curve. Okay? Do not make use of the line. That is just parallel with the unknown line. It has nothing to do with your point. Okay? So that is the reason why we are using your equation of the curve as the second equation. You have here the explanation. I wrote there an explanation why we are using. Okay, so let's take this one as equation 2. So from this equation 1, equation 2, equation and equation 2, that is now algebra. But since I have here a board, let me show that one. I did not show here because that will be a little bit long solution. So it says there from equation 1, equation 2, you will be having values of y. Okay, so what will I do? I will show you the algebra part. But you should already know this one since you are expected that you pass your algebra. As I've told you, the previous mathematics will always be used in your higher mathematics. So, okay, you have your equation of curve x squared plus y squared equals 5, and you have the equation of the point, which is x equals negative 2y. That's why I put this one in this manner, this equation 1 into this manner. Why? So that I will be using in algebra, I will be using substitution. Substitute your equation 1 in your equation 2. So that x will just become negative 2y. So that is what I will be doing on the algebra part. I will substitute 1 in 2. So that will become, x will become, all of the x, if there are a lot of x there, just make it as negative 2y. So x will be negative 2y. Do not forget that this is squared plus y squared equals 5. That will be positive for y squared plus y squared equals 5. And then of course play around with this. That will be 5y squared. So y squared is equal to 1. Get the square root since we are solving y, not y squared. So get the square root of both sides. You will be having here y is equal to positive and negative. Okay, do not forget about this. Square root will always be a positive and negative. So you have two values, a positive and a negative 1. That's how your values here is solved. Y1 is positive and negative. Okay, we are talking here of points. What we are trying to find is point of tangency. So it should have a coordinate of x and y. So what we have is only y coordinate. From where will I solve that one? I will go back to equation 1. Okay, make use of the equation of the point again. Do not make use of any equation there. Just go to the equation of the point. It's either go to the curve or go to the equation of the point. But it looks like we have here a simpler equation in your curve. So I will make use of that. Substitute the positive 1 in your y here in your equation 1. X will be negative 2. Substitute negative 1. That will be positive 2. So you have 2 points of tangency. Ibig sabihin, dalawa yung point ng tangency natin. There are 2 points of tangency. Therefore, there will be 2 tangent lines. Okay? There are 2 points. There should be 2 tangent lines also. So, let me, okay, sige. Let me, okay, right here, we will have point 1 as, okay, x1, y1, negative 2 and 1. So that is your coordinate for the first point of tangency. And then 2 and negative 1 for the second tangency. So making use, okay, get the equations of tangent lines. There are 2 again since there are 2 points of tangency. So you have there from the first point of tangency negative 2, 1, and using the slope which is 2, I will end up here. So I will not show you that one. That is just the point slope form. Again, please do that one. That is the point slope form. And then from the point of tangency to negative 1, I will be using the slope of 2 again since that is the same as the tangent. From the point slope form, you will end up with 2 negative y negative 5. Okay, so that those are the equations of our tangent lines. Now I think I did not draw this one. Sige, let me show you. Since I have here a grapher, let me show you the drawing of this. Oh, let me just copy that one so that we will be having drawing. Okay, so you have 2 tangents. Copy first the curve. X squared plus y squared equals 5. That is your curve. We will plot that one in the grapher. You have a parallel line. This is 2x minus y equals 4. That is the parallel line. And the tangent lines, which are 2x minus y plus 5 equals 0, and 2x minus y minus 5 equals 0. So I will just be copying that those are your LP or tangent lines, so that we will be inputting that one on the grapher. Okay. My laptop is already old, so it's a little bit weak. Okay, so this is my grapher. So as I've told you before, you can download the grapher for you to have an easier way of graphing. But if you want, you can always graph that one manually, but that will take time. Since our subject is not algebra, I will not, of course, be strict on your graphing. I will not investigate if you really know how to graph, but you should, because that will always be a tool if you will go on your higher subject. Okay, so in my grapher, I will be inputting the curve itself. Oh no, that's not no. Okay, let's say again that is x squared plus y squared equals 5. Okay, let me put a color for that. Let's say that that will be the red. Okay. Let's make it a little bit larger, thicker, I mean. Okay. So that is just actually ellipse. Why ellipse? Because isn't it Is that an ellipse? I don't think so. This is a circle supposed to be, but my tingnan nyo yung ito. Look at the numbers. That should be circle. My grapher is just elongated it because he did not put equal yon. So look at this. This is 2 point something. That is 2 point something from the origin. That is 2 point something. So that should be circle. The grapher is using not equal distributions on the y and x, but that should be circle. Okay, so I will be adding here another line, another equation wherein the parallel line, and we will add that parallel line. So I will be inputting here your parallel line. I will rearrange this one so that will become y equals 2x minus 4. So that I will input here the function of x only. So that is the parallel line, which is y equals 2x minus 4. So 2x minus 4. Now let me put that one as color, ano kaya yan? Let's say color green. Okay. So this is your parallel line. And then I will input now the equations of my tangent lines. First, I will input the points of tangency, which is at, again, what is the point of tangency? Our point of tangency, negative, let me just check that one. Negative 2, 1, and 2, negative 1. Negative 2, 1, and negative 1, positive 2. Okay. No? Yun ba yun? No. Negative 2, 1, and negative 1. Ano yun? Again. Let's go. Negative 2, 1, and positive 2, 1. Okay, interchange. Positive 2, negative 1. Okay. Yon. So these are your point of tangency. Now I will draw the lines, which is 2x minus y plus 5. So I will transfer x to make it positive. Y equals 2x plus 5. Okay. 2x plus 5. Let's put that one as color black, since that is our unknown. Okay, that's it. That is the tangent at your 2, 1. Okay, let me put the coordinates here. Show coordinate. Okay, yon. So you have your tangent line there. And I will add another tangent line, which is 2x minus 5. 2x minus 5. Okay, so that is the tangent line. So again, this is your function. You have here in the this one, this is your legend. Okay, so the red one is the curve. The green one is just the parallel to your tangent, parallel line to your tangent, and the black, two black there is your tangent lines, and those are your point of tangencies. Okay, so that's it. So let me edit later on. I will give you this on the PowerPoint. Okay, so that is your tangent and normal lines. Okay, so that is your tangent and normal lines. So let me first save this one. We will continue on another video for the rest, so that we will not be having a very long video in each of the videos. Okay. By the way, if you are watching this right now, or if you will open, you will have here your try your own. Okay, try this one in your own. So making use of the discussion on this PowerPoint and making use of the video this video that I will be uploading, then please try to answer this on your own. since on my observation before, only one or two is doing their part. So I will now record this one. Okay, so that is to be submitted before the discussion, for before our Q&A. So I will be opening there your assignment 1-F. So you should be uh, regularly checking, and I know that your Canvas will always notify you. So please always open the notification of your Canvas. Wag mas importante yung Facebook, dapat mas importante yung Canvas, because that is your uh, official platform for the subjects. Okay, so I will be opening. Once I will upload this video and presentation, I will open a submission for the assignment 1-F. So that will only be up to before the discussion. So please take note of this. This is your assignment number 1 for finance, so 1F. Follow your naming. Okay, go to read the instructions carefully. Okay, so please do that in your own, and then I will continue the other topics or the other discussions on another video. Thank you. If you have comments or questions, comment it below.